Right now, your phone can find you. It can drop a little blue dot on a map and point to the exact spot you are standing on, out of the entire planet. You do this 10 times a day without blinking. You tap a button, the dot appears, and you just trust it. But stop and think about what that actually means. You are one person on a rock that is 500 million square kilometers across, and a flat piece of glass in your hand knows where you are, down to the width of a driveway. It works in a brand new city. It works in the middle of the desert. It works on a boat with no roads, no signs, and no one around for 100 miles. So here's the real question. How does the thing in your pocket know exactly where you are? The answer goes all the way up into space. It runs on clocks that bend time, and it almost never existed at all. This is the story of the blue dot. Let's start with the part that surprises most people. Your phone is not calling anyone to ask where it is. When that blue dot appears, your phone is doing the exact opposite of reaching out. It is sitting completely silent, and it is just listening. Listening to what? To space. Far above your head, there is a small fleet of satellites. Every single one of them is shouting the same two things over and over forever. Each satellite constantly announces who it is and what time it is. That is all they say. They do not know you exist. They do not care where you are. They just broadcast into the void, around the clock, to anyone who happens to be listening. And your phone is listening. To understand how that turns into a dot on a map, we have to go back to a beeping ball of metal. In 1957, the Soviet Union launched Sputnik, the first satellite ever put into orbit. It did almost nothing. It circled the Earth and sent out a simple radio beep. All over the world, people pointed antennas at the sky just to hear it pass overhead. Two scientists in the United States were listening too, and they noticed something strange. As Sputnik flew toward them, its beep crept higher in pitch. As it flew away, the pitch dropped back down. It is the same thing you hear when an ambulance races past you on the street. From that shifting pitch alone, they realized they could pin down exactly where Sputnik was in the sky. Then one of them had the idea that started everything. If you can find the satellite from the ground, you can flip the whole thing around. If the satellite already knows its own position, you can use it to find yours. The sky could become a map. The military fell in love with this idea immediately. A nuclear submarine hiding deep in the ocean has a serious problem. It needs to know precisely where it is, but it cannot exactly surface and ask for directions. So the first real system was built for the Navy, to tell submarines their position using space. For a long time, this stayed a military secret. The good version of space navigation belonged to the armed forces, and the rest of the world was not invited. Then in 1983, a tragedy changed everything. A Korean passenger plane carrying hundreds of ordinary people drifted off course. It wandered into Soviet airspace by mistake, was taken for a spy plane, and was shot down. Everyone on board was killed. Part of the reason it strayed so far was painfully simple. Navigation for civilians back then just was not good enough. In the aftermath, the US President Ronald Reagan made a promise. This technology would no longer be locked away. Once it was finished, the full system would be opened up and handed to the entire world for free. That system is the one you use today. We call it GPS. So let's go up and look at it. Circling the planet right now are more than 30 satellites. They sit incredibly high, roughly 20,000 kilometers above your head, far beyond any plane or any cloud. Each one loops all the way around the Earth twice a day. They are spread out so that no matter where you stand, several of them are always somewhere in your sky. They have been up there for decades, quietly doing the same job every second, for anyone with the right kind of ear. Now here's the clever part, and I promise to keep it simple. The whole thing comes down to a single idea. You can turn time into distance. Think about a thunderstorm. When you see a flash of lightning, you start counting. The longer it takes for the rumble to reach you, the farther away the storm is. You are turning a delay into a distance without even trying. Your phone plays the same trick, except with light instead of sound, and with stunning precision. Every satellite message carries the exact moment it was sent. Your phone marks the exact moment it arrived. That message traveled at the speed of light, and the speed of light never changes. So from that tiny delay, your phone learns one solid fact. It knows how far away that satellite is. But one distance is not enough. Knowing you are exactly 20,000 kilometers from a single satellite only tells you that you are somewhere on a giant invisible bubble around it. You could be anywhere on that bubble. That is not a location. That is a guess the size of a continent. So your phone listens to a second satellite. Now you are sitting on two bubbles at once, and two bubbles can only overlap along a single ring. Then a third satellite shrinks that ring down to just a couple of possible points. A fourth satellite erases the last bit of doubt. There is now only one spot in the entire universe where all of those distances are true at the same time. That spot is you. Your phone never went searching for you. It simply listened to a handful of clocks in the sky and found the one place where they all agree. Which brings us to the secret heart of this entire system. The clocks. The whole thing is built on measuring time and not ordinary time. Light is so absurdly fast that it crosses the length of a football field in about a millionth of a second. So, if a satellite's clock is off by even 1 millionth of a second, your blue dot lands a few hundred meters away, on completely the wrong street. These clocks cannot just be good. They have to be almost perfect. That is why every satellite carries an atomic clock. An atomic clock does not keep time with gears or a swinging pendulum. It counts the natural vibration of a single kind of atom, which shivers back and forth more than 9 billion times every second. It is so steady that it would lose only 1 second over millions of years. We built the most precise clocks in human history, bolted them onto satellites, and flung them into orbit. And this is the point where the story stops being clever and starts being almost unbelievable. Time itself does not tick at the same speed everywhere. This is not a theory or a hunch. It is one of the strangest true facts about our universe, and a man named Albert Einstein worked it out long before any of this was ever built. Two things are happening to those satellites at the same time. They are moving very fast, and moving fast makes a clock run a little slower. They are also high above us, far from the heavy pull of Earth's gravity, and sitting up there in weaker gravity makes a clock run a little faster. These two effects do not cancel out. Up in orbit, the satellite clocks end up running faster than the clocks down here on the ground. It is a tiny amount. Each day, every satellite clock gains about 38 millionths of a second on us. That sounds like nothing. It sounds like something you could safely ignore. You cannot ignore it. Remember, a single millionth of a second is a few hundred meters of error. 38 millionths of a second every single day would shove your location off by around 10 kilometers within just one day. Your blue dot would slide off your street, drift out of your town, and keep going. Within a couple of hours of turning it on, GPS would be far too wrong to use for anything. So the engineers did something wild. Before launch, they set each satellite's clock to tick at the wrong speed on purpose. They tuned the clocks to run slightly slow while they are still on the ground, so that once they reach orbit and time speeds up for them, they tick at exactly the right rate. We correct for the bending of time itself, just so your phone can find a coffee shop. Let that settle for a second. Every time you check the map, you are quietly relying on a fleet of atomic clocks in space that were deliberately tuned to account for Einstein's relativity. If we had ignored the single strangest discovery in modern physics, the little blue dot would simply not work. And here's the best part. You do not pay a cent for any of it. The satellites are already up there. They have been broadcasting your entire life. Anyone, anywhere on Earth with the right receiver can listen in for free. You are holding one of those receivers right now. It is a relativity-corrected, atomic, clock-powered window into space, accurate to a few meters across the whole planet. And you mostly use it to find the nearest parking spot and to see how much farther you have to walk for tacos. That is how your phone knows exactly where you are. It is quietly listening to atomic clocks in orbit, correcting for the bending of time, and doing physics that took humanity centuries to figure out. It does this every second of every day, just so you never have to feel lost. Every invisible system around you has a story this insane. The Wi-Fi humming through the air, the power waiting in your walls, the voice that answers when you talk to your phone. We are going to tell all of them. So stick around. There is a whole lot more hiding in plain sight.